So let's first start with optics formulas. So first chapter is optics. So the first formula for optics is mirror formula, which is 1 by V plus 1 by U is equal to 1 by F. Here F is focal length, V is image distance, and U is object distance. Formula for magnification of mirror is minus V by U. And another formula is H dash by H. H dash is height of image and H, or we say HO, is height of object. We have similar formula for lens also. So lens formula is 1 by V minus 1 by U equal to 1 by F. And formula for magnification of lens is V by U. For mirror, minus V by U. For lens, we have only V by U. Okay, next important formulas are formulas related to power of lens. Formula for power of lens is 1 by focal length of lens. Okay, this is in meters. Its unit is meter inverse or diopter. For convex lens, power is positive. For concave lens, power is negative. Next formula for power, when two lenses, they are in contact with each other. When two thin lenses are contact with each other, then their combined power is sum of their individual powers. And their combined focal length will be 1 by F1 plus 1 by F2. Next formula, if we are given with that there are two lenses, two thin lenses, and they are separated by some distance d, then their combined power is it's P1 plus P2 minus d P1 into P2. Okay, so formula for power when two lenses are separated by distance d is this. Okay, last formula is their combined focal length, which will be 1 by F1 plus 1 by F2 minus distance between them into 1 by F1 into 1 by F2. Okay, so these are all the formulas in optics chapter. Next, we have formulas for current electricity chapters. So most of the questions which are numerical based, they are asked from this chapter, from current electricity. Questions are very direct, formula based. First formula is formula for current. Current is rate of flow of charge. Q is charge, T is time. So Q by T, or Q is equal to I into T. Next formula we have for potential difference. Potential difference is work done per unit charge. Third formula is Ohm's law. We derive it from Ohm's law, which is V is equal to IR. Fourth formula is how resistance changes with dimensions, with length and with area. So R is equal to rho L by A, where L is length of the wire, A is area of the wire, and rho is resistivity. Fifth formula is conductivity. Conductivity denoted by sigma. Conductivity is reciprocal of resistivity. Sixth formula is for total resistance when resistors are connected in series. So total resistance in series combination is sum of individual resistances. Seventh formula, total resistance when resistors are connected in parallel is 1 by total resistance is equal to 1 by R2, R1, 1 by R2, and so on. Okay, eighth, we have formulas for heat. These are derived formulas. They are very easy to derive. So you don't have to remember them individually. So H is equal to VIT. Second formula of heat is equal to I square R into T. Third formula for heat is V square T by R. Next formulas are power formulas. So power is energy by time. So E by T, or energy is power into time. So derived formula for power are, there are three formulas which we derive from heat formulas. Okay. So first formula for power is P is equal to VI. This is very, very important formula. Next is I square into R, and last formula for power is V square by R. Okay. When we talk about 1 unit of electricity, we take it in kilowatt hour. What is the unit of power? Next chapter is gravitation. In this chapter, most important formula is universal law of gravitation का जो formula है, the mathematical expression of universal law of gravitation. So it says force between two objects is directly proportional to product of their masses. Let's say we have two objects having mass m1 and m2. Okay, and distance between them is d. So it says it's proportional to product of their masses and inversely proportional to distance between them. So by d square, if we remove proportionality and we have a constant capital G. Capital G is a universal gravitation constant. Its value does not change. It's universal gravitational constant. Its value is 6.673 into 10 power minus 11 Newton meter square kg inverse square. Second formula in gravitation chapter is formula of acceleration due to gravity, denoted by small g. Its formula is gm by r square, where g is universal gravitational constant, m is mass of that planet, and r is radius of that planet for which we are calculating values of acceleration due to gravity. If we are talking about moon, then we put mass and radius of moon here. Okay. If we put these three values for Earth, then G की जो value आती है, that is 9.8 meter per second square. Meter per second square is unit of acceleration. Then we have free fall acceleration formulas. We have three equations of motions, right? So in them, if we replace acceleration due to gravity with, acceleration with acceleration due to gravity, we get these three equations. V is equal to U plus GT. S is equal to UT plus half GT square. And V square minus U square is equal to 2GS. V is final velocity. U is initial velocity. S is displacement. Okay. T is time. And G is acceleration due to gravity. Next formula in this chapter is formula for weight. Weight is mass into acceleration due to gravity. Weight is equal to mg. Okay. Next formula is formula for pressure. Pressure of solids. How solids exert pressure. on the ground on which they are kept, or on the table on which they are kept. So pressure is force by area. Last formula for this chapter is formula for escape velocity. So VE is escape velocity. Its formula is 2gr. R is radius of planet, G is acceleration due to gravity. We know these values. So the value we get is 11.2 kilometers per second. Next chapter we have is motion and laws of motion. Motion and laws of motion. The first very basic formula is formula for speed. Speed is equal to distance by time. If we want to convert meter per second into kilometer per hour, we multiply it by 18 by 5. And if we want to convert kilometer per hour into meter per second, we multiply it by 5 by 18. Next formula is for velocity. Speed is distance by time. Velocity is displacement by time. There is one thing which you have to remember about displacement, and that is that displacement, if initial and final position are same, then displacement is 0. Okay, many questions are asked in exams based only on this point, that when initial and final position are same, take displacement as 0. For example, an athlete moving on a circular track. Third is formula for acceleration. What is acceleration? Acceleration is rate of change of velocity. So change is final velocity minus initial velocity, and rate is time. So formula for acceleration is v by u upon t. Next is, we have some graphs in this chapter, in motion chapter. So how do we calculate slope? So slope is change in x-axis by change in y-axis. For example, we have this graph. This is speed. Sorry, this is displacement time graph. S is displacement, T is time. So slope of this graph would be change in x-axis. Okay, sorry, it's change in y-axis by change in x-axis. Okay. So this needs correction here. So change in y-axis by change in x-axis. So in this graph on y-axis, we have displacement. So write S2 minus S1, we take 2 points, and T2 minus T1. So this is displacement by time. So slope of this graph gives us velocity, because velocity is displacement by time. Okay, so this is velocity. Okay, next we have 3 equation of motion. So 3 equation of motion are V is equal to U plus AT, S is equal to UT plus half AT square, and last is V square minus U square equal to 2AS. Now formulas of laws of motion chapter. Okay, so we have 6th formula. This is derived from Newton's second law of motion. Force is equal to mass into acceleration. Okay, if we write, if we expand acceleration here, so this formula becomes mv minus mu by t. Next is formula for momentum. Momentum is represented by small p. So momentum is mass into velocity. Okay. So this is 7th formula, 8th formula, and 9th formula is law conservation of momentum. Conservation of momentum says momentum before and after collision remains same. It remains, it's conserved. Okay. So let's say we have 2 bodies. Okay. A, B. Initially, they were moving with speed some UA, UB. Then they collided. Okay. After collision, they start moving with velocity VA, VB, because V is their final velocities. Okay. So law of conservation of momentum says MAVA plus MBVB is equal to, MAUA plus MBUB. Okay, so what is this? This is initial momentum of body A. This is initial momentum of body B. After collision, the final momentum is MAVB plus MBVB. Okay, here it should be A. So MAVA is final momentum of body A. MBVB is final momentum of body B. So based on this conservation law, we have formula for muzzle and recoil velocity. So muzzle velocity is velocity of bullet, and recoil velocity is velocity of gun. So when we fire a shot from the gun moves backwards. So that velocity associated with it is recoil velocity, and muzzle velocity is velocity of bullet. Okay, so the formula for this is MBVB minus MBVB, wherein MB is mass of bullet, VB is velocity of bullet, is equal to mg mass of gun and VG velocity of gun. Okay, so muzzle velocity is VB and velocity of gun is VG. So this is our formula for muzzle and recoil velocity. Next formula is formula for impulse. Impulse are forces acting for very short duration. So I is equal to F into T. So these all formulas are of motion and laws of motion chapter. Next we have temperature conversion formula. Okay, I am writing here one formula. C by 5 is equal to F minus 32 by 9 is equal to K minus 273.15 by 5. So if we want to convert Celsius into Fahrenheit or vice versa, we will use only these two. If we want to convert Fahrenheit into Kelvin, we'll take this. Okay, and Celsius into Kelvin, C by 5 minus K by 273.15 by 5. This 5 will get cancelled. So we have very simplified formula. Celsius is equal to Kelvin minus 273.15. Next are three formulas related to work, energy, and power. Work, energy, and power. Okay, formula for kinetic energy, these are very basic formulas, is half mv square. M is mass of object, v is velocity of object. Formula for potential energy of object due to its height, that formula is mgh. M is mass, g is acceleration due to gravity, and h is height of the object from where it is kept. And last formula for work. Work is force into displacement. How much force is applied and how much that object has moved. So force into displacement. Next, we have sound chapter. So there are two formulas in sound chapter. Okay, so first formula is a general formula valid for all the waves. That formula is speed of wave is equal to its wavelength into frequency. Second formula we use for echo. So in echo, sound wave travels twice. It covers double distance. So just we write, instead of D, we write 2D in simple speed distance time formula. So we have 2D equal to S into T. Okay. Next formulas. Okay, next is EMS. order of electromagnetic spectrum, which is very important to remember. So first we have gamma rays, then X-rays, then we have UV rays. In middle we have visible part, or we can write Vibgyor here. Then we have infrared rays, microwaves, and radio waves, and they are in order of their increasing wavelength and decreasing frequency. Wavelength order for Vibgyor is 400 nanometer to 700 nanometer. Okay, next few formulas are important only for NDA. So we have one formula for oscillations chapter. That formula is time period of pendulum. So time period of pendulum formula is 2 pi under root L by G, where T is time period, L is length of pendulum, and G is acceleration due to gravity. Now, next formulas are from matter chapter. First formula is of stress. So stress is restoring force by area. Only two type of stress is important: normal and tangential. So when force is normal, we call it the normal stress. Tangential when force is applied in tangential direction. Okay, so normal, it acts normal to surface. Next we have strain. Strain is a ratio of change in configuration of body. So this is ratio, so this is a unitless quantity. So ratio of change in configuration. So again, two types: longitudinal strain and volumetric strain. So longitudinal strain is change in length of object by original length, and volumetric strain is change in volume of object by original volume. Okay. So these are all the important formulas from physics. So questions from these formulas will be very direct formula based questions. Values will be given. You should just know the formula. Okay. I hope you all perform well in your exam. Thank you, everyone.